Hello, my name is Samantha, and welcome to the first lesson of CCA Girls Who Codes Girls in STEM Java curriculum. Today, you'll be introduced to Replit and some of the fundamentals of Java, which include print statements, variables, and math functions. I'd like to introduce Sarah, who will be the instructor for today's lesson.
Hello, and welcome to your first Girls in STEM lesson. Throughout this course, you'll be introduced to basic Java programming skills. Don't worry if you've never programmed before, we'll walk you through each concept. So, what is Java? Java is a popular programming language and is used for a variety of things, including mobile, desktop, and web applications, web and application servers, and games. We also actually use Java for our robots. Java has a wide variety of applications and is a great programming language to know. Now, we'll be introducing our first concept, print statements. Before we get to that, we'll need to set up Replit, spelled REPL.IT. Replit is a great website where you can write, run, and share your code. When you get to the website, there should be 3 buttons in the top right corner: Login, Sign Up, and Start Coding. If it's your first time using Replit, click Sign Up. If you already have a Google account, click the Google icon and create an account. If not, create your own username, enter your email, and create a password. Now that you've created an account, you can start your first coding exercise. You should see a blue button in the top right corner that says New REPL. It should ask you what language you want to choose. Click on Java, not JavaScript, and name it Practice 1. Then click the Create REPL button. On the leftmost area, you will have access to all of your files. In the center is where you will write all your code. The darkened area on the right will be your console, which is where your output will be shown when you run your code. Now click the green Run button and see what happens. Note that it might take a while to run. What was the result? If you look at the console, Hello World should have been printed. If we look at the slides, we could see in the top right corner a snippet of code. The highlighted region, called the argument, says Hello World! Try changing the highlighted region to your name. Be sure not to delete the quotation marks, because they are very important. Only words, characters, or numbers inside the quotation marks will be printed. The code snippet might look very confusing right now, but let's look at the key line of code in line 3, the print statement. We can ignore lines 1 and 2 for now. We will discuss classes and methods later. In line 3, the system.out.println will be used whenever we want to print something to the console. As we already know, inside the parenthesis, we'll find the argument, which will always be surrounded by quotation marks. Now let's practice. Try printing out multiple lines of code. Type the code on the slide and see what happens. If you come across any errors, make sure your code is the same as what's on the slide. Also remember that every line of code where you are executing something must end with a semicolon. Your code should print out hello and world on separate lines. In the previous example, you use system.out.println hello, and what happens if you change the println to only print? If you look at the screenshot of the console on the screen, hello and world are now on the same line. Be sure to check if you are using println or print when you code. They do different things. Let's keep going. Here, we're looking at protected characters. These characters need a backslash in front to print them to the console. You should find the backslash key on top of the return or enter button on your keyboard. If we look at the code on the slide, notice how the second quotation mark in line 3 is printed because there is a backslash in front of it. Now let's print out a bunny. Remember that you need a backslash in front of all protected characters. For the circle or bunny tail, just use a lowercase o on your keyboard. Pause the video now and resume the video to go over the answer. All the protected characters have backslashes in front of them, and we print the bunny on 3 separate rows using 3 different println statements. Now we'll move on to a different topic, variables. A variable is an abstract symbol that refers to some particular value or mathematical expression. In simpler terms, variables are used to store information. You can name your variable almost anything, including brush size, score, or a letter. However, you cannot name your variable after mathematical values. For instance, 10 or Boolean values like true or false, or text strings like hello with quotation marks around it. You could use hello without the quotation marks, though. In Java, we have data types, which indicate the type of variable. The way you create a variable in Java is to write the data type first, followed by the variable name, and a single equal sign that assigns the value to the variable. The first data type we'll introduce is string. Strings store text and are surrounded by double quotes. Note that, unlike the other data types, you must capitalize the S in string. Next, there are integers. Integers are abbreviated to int, and they store integers or whole numbers without decimals. Floats store floating point numbers, or decimals. Doubles are also variables that store decimals, but can store double the amount of decimal digits, which leads to more precise calculations. Chars, short for characters, store a single character and are surrounded by single quotes instead of double quotes for strings. Booleans store values with 2 states, true or false. Don't worry if you don't understand data types right now. We'll see a few examples that might make this concept clearer. Here, we're seeing how we can use a variable to print out the number 6 instead of printing system.out.println 6. We initialize a variable called num of data type integer and stores the value 6. Follow the code on the slide and click the Run button. What happens? The number 6 should be printed to the console. Note that you must initialize your variable before you call it in the print statement. If we try to move the int num equals 6 line to below the system.out.println num line, we'll get an error. You might ask, why do we need variables? Variables are useful in that they can be manipulated and changed. You'll see more of this in the problem sheets we've linked below in this video. Again, the syntax for initializing variables will always be the data type, variable name, an equal sign, and the value. Now let's practice. We have 3 questions. The first asks us to create a variable that stores a float and prints out the value. Second, create a variable that stores a character and prints out the value. Third, create 2 variables that both store Boolean values, one true and one false. What happens when you print out this code? Pause the video here, and when you're done, resume the video to go over the answer. Here's the key for the first 2 questions. All of these solutions will use the same syntax for initializing variables that we covered earlier. For the first question, we created the float mynum and had it store the value 5.75. Then we use a print statement with mynum in the parentheses. When we create our float, we must have an f at the end. When mynum gets printed, the f doesn't get printed as it just represents the float data type. For the second question, we create the char myGrade and have it store the character A. Remember to put single quotation marks around the character. Then we use a print statement with myGrade in the parentheses to print out our character. Here is the key for the third question. First, we create our two booleans, is correct and is wrong, and set them equal to true and false respectively. Then, we simply write two print statements with the booleans in the parentheses. When this code is run, the values of the booleans true and false will be printed. Next, we're going to talk about data type casting. Casting is used to convert variables between different types. The general syntax for casting is the new variable, an equal sign, the type to cast in parentheses, and the original variable to cast. Before we move on, take a look at the code below and see what you can puzzle out. Notice the usage of the syntax in the casting of a double named myDouble to an int named myInt. Also, try typing the code out in Replit. What does the code print? Pause the video here, and when you're ready to move on, resume the video for an explanation of what happened. When you ran the code above, you might have noticed that although your double had the value 12.01, the print statement with the containing myInt only printed 12. This is because when you cast myDouble to an integer, it cuts off the values after the decimal point and turns myDouble into an integer. This same principle can be applied between most data types. In the final portion of this lesson, we are going to cover the basics of math functions in Java. In essence, the math class enables you to do operations like rounding, absolute values, square roots, and others that are not default in Java. To use these functions in your code, you must import the math class using an import statement above your class. You can see what the import statement looks like in the code below. Note its positioning before the start of the class. If you're interested in reading to figure out what each of the math class functions do, you can look through the Java API and use Control F or Command F to find specific functions. Here is a list of the arithmetic operators in Java. You can see the corresponding symbols or syntax for the different arithmetic operations: addition, subtraction, multiplication, division, and the remainder or modulo. Under addition, note that syntax score, plus sign, equal sign, 20 is the same as score. Equal sign, score, plus sign, 20. The first format is a simpler version of the second version, and the same syntax can be used for other variables being modified by the other 4 arithmetic options. Here is a list of a few math functions in Java. You can see the corresponding syntax for different math functions: absolute value, ceiling, floor, maximum, minimum, and rounding functions. As shown in the examples, the ceil function always rounds up the input value. The floor function always rounds down the input value. And the round function rounds the input value to the ones place according to conventions. Here are more math functions in Java. As with the previous slide, you can see the corresponding syntax for different math functions: random, exponents, logarithms, power, and square root. Note that the math.random function returns a random float or decimal between 0 inclusive and 1 exclusive. In order to obtain a random integer from 1 to 6, for example, you would also need to use the multiplication operator and the math.ceil function. Now, let's practice using the previously listed math functions. We have 3 questions. The first asks us to use the correct math method to find the lowest value of 2 and 5. Second, use the correct math method to find the square root of 49. Third, use the correct math method to find the absolute value of negative 10.34. See the previous reference slides for the syntax. Pause the video here, and when you're done, resume the video to go over the answer. Here's the key for the 3 questions. For all 3 questions, remember to use the system.out.println function to print the output. For the first question, we use the math.min function because we want to find the minimum of two numbers, 2 and 5. Because 2 is less than 5, the code should print out 2. For the second question, we use the math.square root function because we want to find the square root of a value, 49. And because we know the square root of 49 is 7, the code should print out 7. For the third question, we use the math.abs function because we want to find the absolute value of negative 10.34. Because the absolute value of negative 10.34 is positive 10.34, the code should print out 10.34.
Hi, I'm Alexis, and thank you so much for watching. Congrats on completing your first Girls in STEM lesson. If you have any questions, comments, or concerns, please feel free to reach out to us at our email, ccagirlswhocode@gmail.com, or comment down below. I wanted to thank the following on the production team for all their hard work that went into this lesson. All of the slides and videos in this series are available on our website and in the description down below. I hope you'll join us again in our next lesson on if statements.